right now the footings are being constructed for the 40-foot tower that will be standing on top of the building. And it's very important that the tower is well supported and can withstand all of the structural loads that are going to be imposed.
How's it going to look?
Well, I think you have to use your imagination to some extent, but draw your attention to the anemometer tower up there. That's about the height that the final windmill tower will be at the top. The anemometer rotating up there is something like 45 feet over the deck of this roof, and that's approximately the height that the lower part of the windmill is going to be at, except it will be vertically, directly above the center point of those two beams.
This particular project involved in the following way. Barry Lebost, who is the inventor of the Lebost Wind Turbine, came here to us about, it must be about 2 years ago now, and began to tell us about his invention and discuss the possibilities of doing some testing in our wind tunnel upstairs to determine how it performed and how it might be changed to make it even more efficient, a better producer of electricity, a better producer of heat. And much to our surprise at that point, it began to test out as a very, very promising design and extremely high power coefficients, which is the way to measure the output of such machines, came out of those tests. So at that point, we began to talk to the New York State Energy Research and Development Authority. This is the state energy in charge of energy research, about continuing the program and indeed to build what's going to be on the roof of this building, which will be the largest wind energy machine ever installed in an urban environment. That's
the university structure is primarily responsible for the research of the turbine, and that is their expertise. They have the means of doing research here and the people to do it, and Barry and his company Space Age Windmills is responsible for the development of the turbine, the design. He is the inventor, and he has been developing the machine with his engineer. You know, in summation, Space Age Windmills Incorporated is paying for the turbine and everyone's salary involved, and the university has paid for a urban rooftop study, an anemometer study, and State ERDA has paid for the tower that is going to be on the roof of the building.
And once the turbine is up, you're hoping for further funds from ERDA?
Yes, once the turbine is up, we will be seeking further funds from State ERDA for research and development of this machine into a viable, marketable product.
How'd you get involved with this then?
I was working for the telephone company, and I was in charge of several operator groups which had their own power backup supplies in case Con Edison went out. And I was thinking about better ways to get energy than the power company. I guess everybody was a little tired of paying such exorbitant bills, and a lot of people were thinking about wind devices and solar devices, and I guess I just became one of them. I did a lot of work in my workshop with trying to shape static parts around a vertical rotor to make the rotor go faster. It's kind of like working with a hot rod. And the faster it goes, you intuitively know that you're putting out more power. I finally came upon this dome shape and the frontal deflector, which creates a low pressure zone underneath to aid the exhaust in the machine.
It's really a wind turbine in that it looks more like turbine blades being hit by a fluid stream rather than a windmill, which look like these propeller blades of one kind or another. So it's a wind turbine, and it has this big housing around it. Now, the housing is not only for aesthetic purposes and not only for safety purposes, but it increases the performance of the machine on the order of a factor of 2. So, it's a great thing, and at the same time, it makes it look interesting, and also makes it much more safe. At the same time, it has 2 big rudders, like you have on a big aircraft. Now, that's to turn the machine into the wind.
So well, we won't be able to stop it. really looks like it's going to work, and it's a very industrial-looking machine. It's a professional-looking machine. We put a lot of work into it, and I think it's going to do just what it's supposed to do.
What's that?
It's going to produce a couple of 100,000 BTUs in the wintertime per day, and it's going to produce energy at peak efficiencies for all wind speeds, which is something that's not done today by any wind machine.